What have we done so far? This is like in the last unit. Well, we talked about right triangles, so that has to do with slopes, finding slopes. We talked about scaling isosceles equilateral, so that has to do with side lengths. Perimeter has to do with side lengths. So we know how to find length between 2 points, slope between 2 points. Those are the kinds of things we've already done with triangles. So if I give you the 3 vertices of a triangle, there's lots of stuff that you could find out about that triangle. If it's a right triangle, what's the perimeter? Classify it by side length, that kind of stuff. And then yesterday, we started thinking a little bit about areas of triangles. Right? So that's something else that you could do. You could find an area of a triangle. And now we know some properties about like medians and areas of triangles and that kind of stuff. Okay, so this is a slightly different kind of question. Consider triangle ABC. Verify the midpoint of the hypotenuse of the triangle is equidistant to all 3 vertices. So let's plot it first and see if we can figure out what this is talking about. That's point A. B and C. 2, 9. Yeah. Oh, like that. First of all, what's the hypotenuse of a triangle? Ahmed? Sure. How do you know that? Why do you think that? Okay, good. Nick, what were you going to say? With the right angle? Is that what you said? Yeah, it's opposite from the right angle. It is the longest side. So hypotenuse is in a right triangle. So it's implied here that this is a right triangle. And so again, we're not allowed to assume where the right angle is, but it's pretty obvious looking at the diagram. So first of all, let's find out where the hypotenuse is. We'll find the slope. So slope of AB, we're just figuring out where the right angle is right now. This is all that we're doing. So slope of AB is 5 minus 1 over 4 minus negative 4, so plus 4, which is 4 over 8, so positive 1/2. Look at my diagram and ask myself, is it positive 1/2? Over 2 up 1, over 2 up 1, over 2 up 1, over 2 up 1. It is. Use your diagram to confirm your answer. Okay, slope of BC. 9 minus 5 over 2 minus 4. So that's 4 over negative 2, which is negative 2, always reduce. So they are indeed negative reciprocals, and that tells me, therefore, AB is at a right angle to BC. If I found my right angle, I could draw it in there, I could add it in. Now, what exactly is this question asking us to do? Verify that the midpoint of the hypotenuse is equidistant to all 3 vertices. What do you think equidistant means? Sarah? Same distance away. Equidistant. That makes sense, right? Equidistant to all 3 vertices. Okay, so let's find the midpoint first. So midpoint of AC, because AC is our hypotenuse. x1 plus x2 y1 plus y2, not minus. So we're doing AC here. So negative 4 plus 2 over 2 and 1 plus 9 over 2. So that's negative 2 over 2, which is negative 1. And 10 over 2, which is 5. Again, let's confirm that. Like, I'm going to graph it, because why wouldn't I? Negative 1, 5, there it is. Yes?
Could you explain
So it might make a bit more sense once we're finished. I found the slopes because I have to show where the right angle is. Unless you're told that the right angle is at vertex B. Like, the question might tell you that, so then you don't have to find slopes, but you're not allowed to assume anything. So we have to show that the right angle is at angle B, or vertex B. So I find the slope of AB, the slope of BC, show that they're negative reciprocals. That way I know where the right angle is. That way I know where the hypotenuse is. Because it asked me about the midpoint of the hypotenuse. So now I've got the midpoint of the hypotenuse. And I use the midpoint formula to find the midpoint. There it is. Of the hypotenuse, which is AC. Now, then you wouldn't be able to do it. So if you were given a question that said that do this, and it wasn't a right angle triangle, then like there's a mistake in the question or something like that. That's okay. Now what does equidistant mean? It means same distance, equidistant to all three vertices. So that is this distance, and this distance. That's the three distances that midpoint has from each of the vertices. I know that these two are the same. How do I know those two are the same length? Yeah, it's the midpoint. So it's halfway, exactly halfway. So of course, those two line segments are the same length, right? I know that. So I have to check one of them, and I have to check the distance. So we'll call this point M, and I have to check the distance from M to B. So I'm going to find the length okay, so the length of, doesn't really matter, but I'll find the length of AC, AM. So that's 3 squared, which is 9, and 4 squared, which is 16. So 9 plus 16 is square root 25, which is 5. That one worked out. If it didn't work out and it gave me a decimal, I'd leave it as an exact answer. Now I'm going to find the length of MB. So that's 4 minus negative 1, which is plus 1 squared. Plus 5 minus 5 squared. So 4 plus 1 squared is 25. Right? 4 plus 1 is 5. 5 squared is 25. 5 minus 5 is 0. 0 squared is 0. Square root of 25, which is 5. So I know length AM equals length MC, because it's the midpoint, it has to be true. And I just showed that it also equals the length of MB, because I found the length of two of them. Therefore, the midpoint of the hypotenuse is equidistant to all three vertices. Natalie. Yeah, I think that's a good idea. Because you're saying why something's true. Not just that it's true. It's true because of this. So since this is true, therefore. Any other questions? So just to go back over it, we graphed it. We kind of figured what the hypotenuse was, but we had to find two slopes to prove where the hypotenuse is, so that we could find the midpoint of the hypotenuse, and then find a couple of lengths just to compare the length of the midpoint to angle C or vertex C or vertex A, and the midpoint to vertex B. And now I know each one of those distances is 5. And so all three, the distance from the midpoint of the hypotenuse to all three vertices was the same. That's what we were proving ultimately. And that's how we did it. There's another question, and it's in the practice again today, that's not quite the same, but it talks about midpoints and like connecting midpoints and talking about things being parallel. So it's kind of the same. Like it's a common problem, and it's probably the kind of thing that you would expect to see on a test. But I'm going to let you try to work through that one on your own. But if you don't get it, make sure that at some point you ask, or we can take it up tomorrow or something like that. Ben?
Is this true, like, with all rectangles?
Yes. It always works. But it would be interesting, like you could use GeoGebra and build yourself a little triangle and start dragging vertices around, but make sure it's always a right triangle, and like show that. Like kind of, you could explore that yourself, right? Yeah. Okay. So here's what we're going to do. Consider the graph below. With only the information that's given in the picture. So what are you given? You're given the 3 vertices. And there's a line there that goes through point D. And there's some extra information. I don't want anybody to shut it up, so I want everybody to draw their own conclusions. So, but there's information down there about what's happening with point D, right? So what do you know, given this, and there's a line that goes from A to D, right? So that's a line that goes through it. So first of all, I want you to answer this yourself. Question A, you might say, like 1 or 2 things that you know about the triangle. Question B, what do you know about the line? What do you know about it? You might be able to come up with a few things. And then C, I think is the hard one. List all the things you could determine from the information that's given. I came up with, I think, like 18 or 19. Counting, like, sometimes you can kind of come up, it's like the same thing, but there's 3 of them. So I counted that as 3 different things. Anyway, think about that. So I want you to just take a minute and do it on your own. And then you're going to share with the person you're sitting with. And then we're going to keep kind of sharing with other people. So you're going to get a chance to hear other people's opinions, but come up with as much as you possibly can for all of that ABC by yourself before, and I'll tell you when you're allowed to start talking. So no talking until I say. Okay, go ahead and try that. Okay. What did you get for A? Somebody, what did you get for A, Nick?
Everything or just some of it?
Yeah, tell me one thing.
That D is the midpoint.
D is the midpoint. How'd you know that? Shh.
Well, for one, it looks like it's in the center, but then see the two lines?
Yep.
Those two little straight lines, that means like either side of them are the same length.
Okay, very good. So those little tick marks are hash marks. There's 2 on one side, 2 on the other. It's got to be the same number, right? This is, I know you all know this from grade 9 and from elementary school. Tell us that the length from B to D and the length from D to C are the same, so that's the midpoint. The fact that it looks like the midpoint is irrelevant to us, right? We want to know for a fact that it is, and you're right, you can say that. You could also calculate it, yes, but the diagram tells us that. Very good. Okay, something else. Nick?
The triangle is isosceles.
How do you know that?
Because the parallel lines or marker lines. We know that both sides are the same length, and the line that goes to the middle perfectly splits in half, so it's isosceles.
Okay, good. A lot of people got that. That was good. That kind of came out of what we were doing yesterday, right? You can tell that this is an isosceles triangle. Okay, very good. B, what do you know about the line? Phil? Very good. So it is the altitude, right bisector, and the median. Ben? Bisects the triangle's area. Very good. Yeah. Yeah, it bisects the angle. Very good. Also, so like angle, this little angle here and this little angle here, it bisects. Those angles are going to be the same. Okay, very good. Okay, C, list all the things you could determine from the information that's given. So let's see. Give me like 1 or 2 kind of things, Natalie. Don't give me everything you got. Slope of AC. What else? Like, what other slopes related to that? Yeah. So slope of AC, AB, and BC. So the slope of the 3 edges. So that could count as 3 things. You know? Length of the 3 edges of the triangle. Very good. What else? Whoops. Area of, like, which triangles? I mean, all of them, right? But like, what are, like, how many triangles? Have you ever seen those pictures? How many squares do you see in this? And you have to count them all, and there's some inside others. So, like, this is a triangle. There's the big one. We could find that area. There's this one. We could find that area. And there's this one. We could find that area. So there's area of the 3 triangles. Good. What else? Perimeter. Nice. Perimeter of everything, I guess. Right? Yep. So perimeter times 3. Perimeter of the big triangle and the 2 small triangles. What else? There's more. Natalie? So which is the line that we're looking at? Yep. So the median, like the equation. That's what we did in the last unit.
Can you find like the median, right bisector, and altitude for every single possible one?
Yeah, I think you probably could.
All 3 triangles?
Yep. Yeah. You could find the median, altitude, right bisector of the smaller triangles too. It would be a bit of extra work, but you could find that. Very good. So that's a lot of things of all triangles. Anything else? Sarah?
If you drew all the medians, there'd be like a point where they all stop.
What's that called?
So inside.
Yeah, what's that point called from yesterday? Who remembers? The centroid. So you could find the centroid.
You actually like calculate the index like
Right now?
no, I don't mean like can you actually
Yeah, you would find two medians, and then find their equation, and then what we did the last unit, find the point of intersection between those two lines. And that would give you the point of the centroid, which would have to be on the third median. So you could check it if you had the third median as well. There was a question when we did the median stuff, I made it a bonus question like optimal, but question number 4 on one of those sheets that talked about doing that. What else can we find? So we talked about lengths of all things, perimeter of all things, area of all the things. What about, we didn't talk about this. This isn't something we've done, but you could do this. I could find the equations of the 3 edges. Like if we had to do that, that's something we could do, right? You've got 2 points. So like edge AB, what's the equation of the line that line segment's on? That's I think that's more than 18 or 19 things. I think we got more than that. So there's other stuff that you could talk about, like other medians or midpoints. We didn't mention the midpoints. I could find the length of that line. I would have to if I was finding the perimeter. I can find the midpoint of that line. I can find the midpoint of all those things. It's hard to find the median, but there's lots and lots of stuff. Very good. I think that's a good. Everybody relax. I think that was very good reflection on all the things that we're able to do. Okay, so here's a practice.